Welcome, everybody. We have Pasi Tuohimaa from Finland, and he's going to be talking with us about the Olkiluoto spent nuclear fuel repository in Finland. And they are really the only one who has successfully pursued this so far. So I'm going to turn it over to Pasi now. He's going to tell us his story.
Hello, everybody, and greetings from Finland. My name is Pasi Tuohimaa. I'm a communications manager for Posiva, which is the company that is taking care of the final disposal of the Finnish spent nuclear fuel. We are just about ready to start the real operation, so we are quite far.
So Olkiluoto is pretty much built at this point. And how long has it taken you to construct this and do the design work and everything?
Well, the whole process has been quite long, but I actually looked that in October, it's exactly 20 years since we started excavating the underground facilities.
Okay.
So it's been a long way.
Was there a long process in site selection, or was that fairly straightforward in your case?
The site selection was, of course, the whole world was very different at that time. There was no social media, there was no quick medias. We started it in the end of 70s, and in the beginning we had more than 100 sites all over Finland, but then we found out that the bedrock in Finland it's quite suitable almost everywhere. So then we decided that the best places would be close to the power plants where there's also suitable bedrock, and because people were used to nuclear power, we had a really good track record. So did the other place, Loviisa, east from Helsinki. And actually, in the end, there were just 5, and then 2 of the nuclear sites, they were really on the municipalities around them. They were really competing that which one of them would get the site. Yeah. So it's been quite interesting, and that has been our message that the more people know about nuclear, the less they fear about it.
And then how big is the nuclear sector in Finland? How many plants do you have? And what percentage approximately of the Finnish electricity are provided through nuclear?
Finland now has 5 functioning reactors, 2 east from Helsinki and then 3 at our site here in the west coast of Finland. The annual amount of nuclear energy or electricity in Finland is something like 45-46%. Now we have the first 5 final disposal tunnels ready to take the oldest cooled spent fuel, and then it goes in terms that then we continue excavating later on, and if everything goes as planned, we will continue for the next 100 years. Oh, this is shortly Finland's approach to final disposal of spent nuclear fuel, and I put the Diablo Canyon decommissioning engagement panel there as well.
Thank you.
The headlines. First of all, there's a picture of Olkiluoto Island. There you can see up there our 3 reactors. Olkiluoto 1 in the middle, Olkiluoto 2 on the right, and then Olkiluoto 3, which is the newest one in Europe at the moment. It's 1,600 megawatt power plant. So and it came to commercial production last year. So it will continue at least 60 next years, and then you need to cool down 40 years the spent fuel. So that's where the 100 years comes. We have all the waste management in one island. We have the decommissioning waste repository in the end of the island. We have operating waste repository, which is low and medium level waste, contaminated things from the power plants. Low level is tools, overalls, things like that, and the medium level is the kind of waste that we get in filters from the steam, particles from the steam, and then we put it in bitumen and pack it and put it down.
So everything except for spent fuel, pretty much, right?
Yeah, there we have the interim storage for spent fuel. There's 3 pools, and we built 3 more pools. So all the waste that has been produced in this island during the last 45 years, it's there. And then here in the front, we are building the encapsulation plant and disposal facility for spent fuel. It's always better to put it underground to a half kilometer almost than keep it on temporary storages. And people here, so do we feel that our generation that has decided to make nuclear energy. It's our generation's responsibility to also take care of the waste and not leave it to the solidarity of the future generations or future taxpayers.
So why don't you take us into the guts of this thing and show us the tunnels and everything that you have there.
Well, here you can see also in this picture, here on the left upper corner, there's a long tunnel. These tunnels, which you can go down by cars and vehicles, it's 5 kilometer long tunnel, and it goes, there's like a small village, the technical area down there, and then the 5 first tunnels are there. But let's move on.
How long do you have to store this material for it to be non-dangerous to people? I think in a documentary I saw the expectation is 100,000 years. Do you agree with that?
That's a requirement. That's from the regulator. They've decided that if you do this final disposal of spent fuel, you have to guarantee it's safe for at least 100,000 years. And we have the saying that we have taken the uranium from the rock and we put it back to the rock. Well, this shows the time scale that how we started, and it's in the end of 70s. There was site investigations, then the detailed design, which we did together with the Swedes, which is this multi-barrier system. Then we started to excavate it in actually 2004, but first it was a research facility. And then we got the construction license in 2016, and now we are just about to start the operation, and it will end somewhere there 2120. Like I said, only safe final disposal is possible. This is the multi-barrier principle in shortly, that you have the pellets, which ceramical pellets, then fuel rod, fuel assembly, inner canister, which is cast iron, outer canister, which is copper. Then we have buffer bentonite clay around it, which is it swells when it gets a little bit humidity, but then it's flexible also if there would be any rock movements. And then in the end, there's this almost half a kilometer of bedrock. But the capacity of the whole repository is 6,500 tons, uranium tons, and that means something like 3,250 canisters, which are like 6 meters long. They are quite big ones. Footprint, it's about 2 square kilometers. It's in this island. We are not under the power plants and we are not under the sea, so we're here. And we are excavating volume will be in the end of the project about 2 million cubic meters. And there will be, we now have like 10 kilometers of tunnels, and in the end there will be like 50 kilometers of tunnels.
Okay.
There's some pictures where we are. There you can also see the structure here in the middle. We have already underground canister receiving station. We have canister storage rooms. We had a lot of air conditioning works. They all completed now. There's a personal shaft, which is 450 meters. It's really fast elevator. That helped a lot because it used to take like 25 minutes to go down. Now it takes 1 minute, 6 seconds for the people. There are pictures of the first real final disposal tunnel. It's 350 meters long. There will be holes every 6 meters, and that's deep underground. There's drilling machine, another one. There's also, you can see a hole drilled underneath. Encapsulation plant, it's really 500 million euros complex, which everything is done remotely. You can see here the room number 2, which is the encapsulation chamber where all the magic happens. There are docking station for the canister and the fuel transfer cask. There are drying station for the spent fuel and also the fuel handling cell. It's quite special.
It's all robotic and done by machines, right?
Yeah, it's all robotic. No human beings can be there when you have highly radioactive stuff being capsuled. There's a newer picture, what it looks like now. These were a bit older ones, but there's a fuel transfer machine in there, and everything is done automatically. And we are exactly testing it just right now.
Okay.
We have a canister welding and machinery station. That's on the line as well. So the capsules are upwards, and just the end of it, it's in the encapsulation chamber, and it goes down. It moves in the line in the corridor, and then it pops up in the welding station. It's welded. It's actually a US-made welding machine, the Bond Industries. Then it comes down, and it's being machined. The machining is done, and then it moves on to the storage on the ground level. And this is the canister transfer trolley in the canister transfer corridor, where the huge 6-meter capsule is upwards.
And what was the total cost of the entire site, and including the design and construction?
No, well, we've said that so far that when we'll start the operation, we have spent like 1 billion euros. And then when we move on, we have calculated that will be like 40 million euros every year as keeping the process going. So that's
does
very
that 1 billion euros, does that include the encapsulation plant, which you said was 500 million?
Yeah, because excavating is not that expensive. It's the technologies in the encapsulation plant and the elevators, they are the costly things.
Okay, interesting.
But I know many waste organizations in the world, they have spent much more money and they still haven't got anything, but it's just,
right.
you know, but that's our expenses.
And
then in the end, you could say that it's like 5 billion euros, but that's hypothetical because it's so much in the future.
Was there opposition to this, or was pretty much the citizenry of Finland on board with this? Was that a difficulty for you?
Yeah, in the beginning, when the site selection was in the different places and people didn't know, if you go north and eastern Finland, they didn't know about anything. They didn't have any experience. They didn't know about the safety culture in the power plants. They were very skeptical. And our message is that it's really difficult to go somewhere where people do not have industrial identity or nuclear identity. And this has been the message to a lot of our customers worldwide, that it's better to start looking the place where you already have trust, where you have been open and transparent, and people know your safety culture. They have family members, they have friends who work in the power plant. They are not scared. They know it's like, you know, in Diablo Canyon for sure.
Yeah.
So I just wanted to confirm the total cost, because I think I read it was about 3.9 billion US dollars total cost. Do you think that's a reasonable figure?
I think it's more, but what is the total cost? Is it now, or is it after 100 years? It's really difficult to, I would say it's 5 billion euros in the total cost in the end. But right now it's 1 billion.
And then secondly, when you think about 100,000 years, I think if you call a generation 25 years, that's about 4,000 generations where this will be stored. And I guess the question that comes to mind is, for future generations, are you going to try to warn them to not go down there and discover this toxic material? Or conversely, are you going to try to hide it so people don't think about considering what's down there? Or is there some other approach that you're considering?
This is the question I've asked quite often, but the concept is we had the really, really philosophical discussions a long time ago, and we decided that there's no need to mark it at all. The thing is that as long as we are here, as long as future generations, as the societies are like they are now, of course the information is there. But then if you think next ice age, for example, after 10,000 years or something, when there's 2 kilometers of ice on top of Europe, there's no Paris left, there's no London left, there's no industries left, no Helsinki, no Stockholm, everything is demolished. Or if there would be a meteorite or a huge explosion in the world, that everything is disappeared, and then some human kind of people, they start, you know, living again. How do we know what kind of language, what kind of signals do they understand? And then if you would mark the site, it would all be demolished anyway by the ice. So there would be nothing left. So it's better to put it down fill up the tunnels, put back the granite and the rocks, and just close it, and then it's there.